Blood platelet. Platelets are non-nucleated, disc-shaped cytoplasmic fragments with a diameter of 2 to 4 micrometers, originate from megakaryocytes in bone marrow. Platelets are also termed thrombocytes because they are not whole cells. Normal platelet count range from 100,000 to 300,000 per microliter of blood. In stained blood smears, platelets often stick together and aggregate into clumps. Each platelet has two regions: granulomer, a central zone containing purple granules; hyalomere, a peripheral light blue stained transparent zone. EM. Granulomer possesses a variety of membrane-bound granules. Hyalomere lies a marginal bundle of microtubules, which helps to maintain the platelet's ovoid shape. Microfilaments contribute to the movement and aggregation of the platelets. Platelets play an important role in controlling hemorrhage. They function in blood coagulation by aggregating at lesions in vessel walls and producing various factors that act in clot formation. They are also responsible for clot retraction and contribute to clot removal. Last part, let's study hemocytopoiesis. Hemocytopoiesis is the process by which blood cells are formed. In the stage of embryogenesis, blood cells originate successively in the yolk sac, liver, spleen, and bone marrow. The bone marrow participates in hemocytopoiesis at about 6 months gestation and assumes a major role thereafter. Bone marrow includes two types: red bone marrow and yellow bone marrow. Yellow bone marrow, which is filled with adipocytes, is not hemocytopoiesis, but with a potential to become so if necessary, such as severe bleeding or hypoxia. In adults, red bone marrow is blood-forming one. Red bone marrow is due to the presence of numerous blood cells, which is composed of stroma, hematopoietic cores, and sinusoidal capillaries. The stroma is a meshwork of reticular cells and reticular fibers. Sinusoids are formed by a thin layer endothelial cells. Differentiated blood cells from the hematopoietic cores enter circulating by passing through openings in the endothelium. This is red bone marrow. In addition to production of blood cells, red bone marrow is also involved in destruction of erythrocytes and subsequent storage of iron, the production of undifferentiated B and T lymphocytes, which are carried by the blood to the primary lymphatic organ. Hematopoietic stem cells are free cells which arise directly from the embryonic mesenchymal cells and have a strictly hematopoietic potential. Characteristics: self-replication and multiple differentiation. Maturation of blood cells is divided into 3 stages: problast stage, blast stage, and mature stage. Morphological and histological changes in the course of maturation blood cells include: the cell volume decreases, the nucleus diminishes, the cytoplasm increases, self-replication diminishes. Now let's look at the clinical case. The components of blood include blood cells and plasma. Blood cells include erythrocytes, leukocytes, and platelets. After losing blood, the blood in the body will be redistributed to important organs, so the patient will appear pale. Okay, that's all. Thank you.